So once we have a discrete random variable, and once we've written down what its PMF, its probability mass function is, we might also be interested in what do central values or average values of this random variable look like. And this is captured by an idea whose mathematical name is the expectation. So the expectation is a mathematical thing that is defined for a random variable like this. The expectation, this is a double struck E for expectation of some random variable x, is sum up over all the possible outcomes of the probability of that outcome times the value of the random variable on that outcome. That's all a bit abstract, right? And we were trying to avoid talking about sample spaces and everything. So what's convenient to do is to gather together all the outcomes that lead to the same value of the random variable. And then it becomes this. Sum over all values of x in the range of x times p of x. Now, p of x here is, of course, the PMF, the probability mass function. So that's what the expectation is. It's the sum over all values of x times the probability mass function of x. Now, in some ways, expectation is a slightly unfortunate word, but it's just a word for that thing, the sum of x, p of x. It doesn't necessarily mean that that value is an outcome we expect in the normal English language sense of the word expect. For example, you might like to work out that the expected value of a single dice roll is 3.5. But of course, in the normal English language use of the word expect, you don't expect to roll 3.5. That's just the mathematical definition. We'll also see later on in the course that it can be seen as a sort of long-run mean, as in if you roll the dice lots of times, you might expect the mean to be close to 3.5. So just remember that expectation is the mathematical name for that sum of x, p of x. It doesn't necessarily mean anything in English language that you might expect it to. So, let's do some examples. The Bernoulli trial is rapidly becoming our favourite discrete random variable. X is Bernoulli p. Well, this has two possible values. The expected value of x is sum over x, p of x. It takes the value 0 with probability 1 minus p. Or it takes the value 1 with probability p. That all comes out as p. So the expectation of a Bernoulli p random variable is p. What about if x is the total of two dice rolls? Well, again, we have to do the sum, x, p of x. So we take the value 2, probability 1 over 36. We take the value 3 with probability 2 over 36. These are all the values we saw from the PMF earlier. I'm not going to write them all down, but up to getting a double 6, giving us a 12, probability 1 over 36. And if you add up all these, like I did a moment ago to check, turns out you get 252 over 36, which is equal to 7. So the expectation, a kind of central value of rolling two dice, is 7. That's told us about expectation.